The BSides DC 2017 videos are brought to you by Threat Quotient, introducing the industry's first threat intelligence platform designed to enable threat operations and management, and Data Tribe, a new kind of startup studio co-building the next generation of commercial cybersecurity, analytics, and big data product companies.
Hey guys, thanks everyone for coming out, and thanks for coming and supporting your local BSides. Thanks for the community and the organizers for having us as well. So Tom and I are really excited to talk to you guys about a little tool that we wrote called Wordsmith and geolocation-based password generation. So kind of get some formalities out of the way. My name is Sanjeev Kawa. My roots are in dev and IT. I've had a pretty fortunate career so far. I've seen everything from QA in terms of like security-based application testing and functional testing. I've done some Java development, so if there's any Java devs out there, I feel your pain. I've also been on the help desk. I've been a system administrator and a security consultant. I'm currently a senior pen tester at PSC. PSC does a bunch of PCI-based assessment. That's kind of, or PCI assessments. That's kind of where we have that's our bread and butter. And the way that I play into that is I basically spend a lot of my days kind of traversing large enterprise networks, trying to overcome segmentation boundaries and finding card data. Something that I've been getting into a lot recently is just binary analysis and exploitation as well. But yeah, we're always looking for pen testers. If you're interested, come and find me after the talk and we can grab a beer and talk shop.
I'm Tom Porter. Find me Porterhouse on Twitter. I maintain a blog at porterhouse.com. My background's on the blue side, so doing network situational awareness, flow data analytics. More recently, I've been doing penetration testing, a little bit of red teaming. I've done some extensions on the Bloodhound project. I recently joined the FusionX red team as a security consultant there. But my true passion in a previous life, I was a professional baseball player. So if you guys have anything you want to talk to us about our presentation day, you can find us out in the lobby. If you want to talk why the Braves just finished under 500 for the third season in a row, you can find me at the bar.
Yeah, so today we're going to be talking about Wordsmith. At its core, as foundation, all Wordsmith is a a wordless generation tool, but specifically for geolocation data. It kind of got created because Tom and I wanted to work on a cool project together and kind of wanted to write some code together too. It was conceived because as we would go out on site, as we would see more passwords in the wild, we would find that people's passwords would now contain things which are really specific to that area. So things like sport team names or common baby names for that particular area, or even as specific as road names and street names. Now, in addition to that, so what we wanted to do is kind of grab a whole bunch of geolocation data, wrap it all up into a tool so people can dynamically create word lists on the fly. Now, primarily, our first sort of use case was to use it to crack password hashes. And we'll talk about that a little bit later as we do our demo. But something else that we've kind of wanted to do was extend Wordsmith past just password spraying and password attacks. So we started looking at geo-specific username generation. So a scenario might be like you're out in Minnesota and you want to pull down the most common first names and last names and create usernames for a particular client that you're attacking that week. You can do that with Wordsmith now, which is kind of cool. In addition, it's pretty modular and extensible, and as we start progressing throughout the presentation, we'll talk about some of that in detail. So quick show of hands, who's familiar with a dictionary attack? Wow, okay, so that's basically everyone in here. That's awesome. For those of you who aren't, we'll just quickly do a one-slide primer. It's not going to take a lot of time, but essentially, a dictionary attack is, well, I guess one of the first things that you need is a dictionary, and it just consists of a word list. So this particular word list just says apple, banana, and cherry. Our geolocation word list might have things like street names, religious texts, and things to that effect. Now, when you type a password into an application or into a domain, it gets stored in an encrypted format or a hashed format on disk. And the way that it works, it goes through a hashing algorithm. And it outputs a fixed length, high entropy string in most cases. various different hashing algorithms. Common ones are NTLM, MD5, SHA, so on and so forth. But what's really important to note here is that fixed length hashing algorithm can't be reversed in the sense that there's no decrypt function or there's no reverse hashing function, because that would kind of circumvent the intended use case of hashing data. So what you have to end up doing is a guess, encrypt, compare cycle. So using that word list we just talked about, you stick all those words through the actual hashing algorithm for the target hash you're trying to crack, and you start creating these hash strings. And once you compare or collide two hashes that are the same, you can then trace back to the exact word that you have in your dictionary. Yeah, that's basically a dictionary attack in a really simplistic form. So this is our second time presenting Wordsmith. Wordsmith version 1, we presented it at BSides Las Vegas last year. It was our first conference together, and we got a lot of love for BSides. Been really good to us. We met some really cool people. Wordsmith version 1 was very specific to the United States of America, and it kind of worked from a state-down approach. So think of Nevada, for example. You type that into Wordsmith, and it spit out all this data for you. You can see some streets and roads, colleges, and major sports teams. Although I don't think Nevada actually has a major sports team, so bad state example. But you get the gist. It will. Will it soon? I guess so, it will soon. Some of the additional features we built into Wordsmith was we integrated Cool. So not sure if you guys know what Cool is. It's kind of made by DigiNinja, Robin Wood. But let's say you're testing a client, be it grocerystores.com or huge electronicstores.com. You can supply a list of URLs into Cool, and it will go out to that client's website and pull down everything that looks like a string in between all the HTML tags. And so now you can actually really do targeted password cracking once you marriage that with geolocation data from Wordsmith. Wordsmith version 1 also did some basic mangling, so splitting on white space, trimming and adding special characters, and you could also specify minimum character length. So this is quite useful in if you know what the minimum character length is for a domain. For example, 7 would be an Active Directory or Open LDAP, or if you know what the minimum character length is for an application as well. So you can say, I only want to generate words which are 7 characters and above, and just trim everything else out. So a couple of things that we learned from Wordsmith version 1, both after the talk and in the following months, was some of the feedback that we got from the community. And the top 3 requests was we needed to have more countries available, because it was only for the US. In addition to that, the way that Wordsmith version 1 was coded it was quite static in the sense that you couldn't really introduce your own data if you wanted to. And if you did, it'd probably break it. It was also quite limited to the English language. So the way that you interact with Wordsmith on the command line interface, it's still going to be English, but the data sets underneath were all predominantly English based. So taking all those requests, Wordsmith version 2 was born, and we just pushed it out to GitHub today, and there'll be a link that you can grab it from later. But we now collect geolocation data sets for over 230 countries and territories. It's basically every single country and territory in the entire world. And we also have multi-language support. So all the popular languages like French and Spanish and Portuguese and German, those all exist as dictionary files within Wordsmith now. Because this was such a ground-up rebuild, I don't think we actually reused any of the code from Wordsmith version 1. Tom put together a really beautiful CLI, command line interface that you can interact with. I'm just partial to it because I think it's beautiful because we wrote Wordsmith, and so you guys might hate it, but we kind of like it. As we go out on site, as we can see more passwords, we saw that a lot of people are introducing things like gods' names and book names and verse names. So we thought to introduce religions. So we've got a couple of different formats of the Bible, as well as the Quran and some other popular religions in Wordsmith too. So again, primarily it was used as password cracking, but we've now extended that beyond, so you can now start doing some real cool geolocation username generation too, which we'll get into a little bit later. Speaking about a couple of the data sources here, show of hands, who knows about the CIA World Factbook? Cool, okay, so a lot more people than I thought. I actually didn't even know about it until I started looking at some data sources where I can pull data from for Wordsmith, and it turns out, shout out to the CIA, that they've collected a ton of metadata on a lot of different countries in the entire world. So this is kind of what a fact book looks like. I'm gonna make the screen a little bit bigger here. Huge, yeah. So you get some really cool words and a lot of cool dates here as well, like 1776 when the nation was founded. So the chance of that being appended or prepended onto passwords might be high. Primarily, the things that we found that were quite interesting here were kind of these anchor points. So population counts, you'll see why that's kind of cool later on, as well as different ethnic groups and languages, both official and non-official languages of countries and religions. And as you start digging more into the fact book for countries, you'll find that they're pretty well updated, and you'll see things like political party names and current senators and current presidents and things like that too, right? So pretty cool data source. In addition to that, so when we were thinking about the concept of introducing languages into Wordsmith, something that we kind of started with first was just raiding the Nix repositories and grabbing all the language files out of there. But it turns out all those language files are more technically focused and have a lot of operating system lingo and technical lingo in them. And you can't really build a full lexicon of the entire dictionary for a language from those sources. So kind of pivoting off that idea, we found that spell check files, specifically through Hunspell and OpenOffice and LibreOffice, had some fantastic community contributions, and yeah, so we used a lot of spell check files for the languages that we generated, and we found that gave a better, at least more data for different languages. If you guys want to know how dictionary files and affixation files and spell check files work, and want to listen to me, drone about them for about an hour, we can talk later. But it's not that interesting. Some other data sources are Wikipedia, which can be a nightmare to parse just because of all the span tags and div tags. So if you guys want to learn how to do that really quickly and efficiently, I can tell you guys about that a little bit later as well. But we're covering most of the US in terms of sport teams in colleges and universities, and we've got almost entire world coverage for landmarks and archaeological sites. So if you're looking at Italy, you're probably going to have a lot of famous landmarks in there as well. Project Gutenberg is another data source that we're using, and it's kind of like an open source mindset community where they're kind of digitalizing cultural works of this sort, and they promote the creation and distribution of this work. So that's where we're pulling most of our religious texts from as well. Yeah, some of the other data sources like OpenStreetMap and US Census data, Tom spent a lot of time looking at that. So I'm going to pass it off to him to speak about those. Cool.
Thanks, Ange. So OpenStreetMap, for those of you not familiar, it's this community of mappers who have come together to basically build their own open source version akin to Google Maps. And we can take that data, download it, and parse it locally to grab interesting things. And this was kind of our first foray outside of US being our initial purview of Wordsmith, now branching out across the world. So for now, we're grabbing roads, cities, and counties, but there's other data too that we're going to grab from there. The United States Census is our canonical source for area codes and zip codes, and we can do some interesting things with those with appending and prepending and some of the attributes. And the Social Security Administration maintains this list of the most popular baby names in each state dating back to 1910. So we can take that data and do some interesting attributes and some username generations, which we'll show. So to get Wordsmith, if you're at the command line here, you just do a git clone of the repository URL. This is included again at the end of the presentation. Then you cd into the directory. Then you can optionally run this bundle install. We include this gem file to help with that. That's only necessary if you want to use those cool integrations, but it's not mandatory for Wordsmith to work. It'll work out of the box with all the other options. When you run Wordsmith for the first time, you'll see the output that looks like that. It's going to unpack some data and create a data directory where all the flat files are stored for querying. So this is what that structure looks like. We recommend that you check out the README first, or look at the examples with the -E flag. They're pretty similar. And I'll give you an overview of different components of Wordsmith and how you can interact with it. The primary Ruby script down there at the bottom is wordsmith.rb. The compressed data archive that we include all of our words in is at data.tar.xz. And so upon first run of Wordsmith, it's going to unpack that data and then create that data directory that you see there near the top. So when you're using Wordsmith, there's two kind of primary components that you need to be aware of. You need to select your boundaries, which are your inputs, and then your attributes, which are the types of words that you're getting. So on the boundary side, those are specified with the $I flag or the input flag. And those are all the areas of the world that you want to get data for. So it might be at a particular country. Some of those countries are broken down into states or provinces. Sometimes they go down even further into cities. We even have this notion of custom regions. It's something that we created so you can build these custom mappings of certain boundaries and marry them together. So you specify your boundaries and you specify your attributes. On the right, you see some of the different attributes that we have. So cities, colleges, landmarks, and so on. If you look at the example at the top, you can see what an invocation of this would look like. So it's Ruby, Wordsmith, -I, USA is our boundary input, and then -R for roads and -L for landmarks. Now, using those boundaries, it helps to know a little bit about the structure of that data directory, because that's what we're querying. So if you look at that data directory at the top level, you see all of these subdirectories that are 3 letters long, and they correspond to the ISO alpha 3 country codes. So the US would be USA, Great Britain's GBR, Germany's DEU, South Africa's ZAF, and so on. And this is kind of the top level when you start drilling down are the countries. If you go into one of them, say the USA, you'll see these broken out by 2-letter state abbreviations. We do something similar with like Canada with our provinces. We see Alaska and California all the way out to Wyoming. There's also some text files that will start residing in these directories. So you see CIA.txt there. That's one of our attributes. That's all the data that we've parsed out of the CIA World Factbook for the US. So if you were to use that CIA option as an attribute, you would get the data that's in that text file. A lot of these countries also have a YAML file. It's like kind of our configuration file where we're storing some metadata about the country. If you drill down further, so here in the North Carolina directory, you see even more attributes. And this is where most of our data resides, in the US at least. So you see area codes of North Carolina, cities of North Carolina, and so on. And you can even define more granular restrictions if you wanted to. So if you wanted a boundary of Charlotte or the city of Charlotte and include a text file in there like sports.txt, you'd look at it and you would see Charlotte Hornets and Carolina Panthers. So how does that translate over to the Wordsmith command line? Basically, you're just taking all the subdirectories and substituting hyphens. So if it's USA, it's just USA as your input. If you're interested in North Carolina, it'd be USA-NC. Charlotte, be USA-NCU in Charlotte. If you want to specify multiple boundaries, you can do that too in the command line. It's just a CSV format. So for USA and Canada, be USA, CAN. If you want the DMV area, be USA-DC, USA-MD, USA-VA. With the CIA World Factbook data, one of the elements we could pull out were the populations of each of the countries. So we took that and we ranked it from most populous to least populous countries. And with that, you can now supply a number for your input. So if you give it a number of 10, it's going to go out and grab the 10 most populous countries, 25, 50, whatever you're interested in. So what if you want to get data for a very large region and you don't want to type out all these different countries? Like maybe you're interested in getting all the data for Europe. We have this notion of a region. So you see this regions.csv file, it's basically like a configuration file. We're grepping out the Europe alias. So the way it's structured, your alias name is going to be that first value of Europe. The second value is a description of that alias. So this is the continent of Europe. And then the third value are all the boundary members of it. So you see you got Germany and Italy and Poland and so on, all wrapped up into Europe. And then when you go back to the Wordsmith command line, you just specify your alias of Europe, and it's going to pull in data for all those different countries. Now, Wordsmith comes prepackaged with a bunch of these regions already defined. You can list them out with the $R flag. So here are some examples from the US. You got New England, and we broke it down to Southeast and the Far West. We've got world organizations like NAFTA or EU. We've got each of the continents, like South America and Africa. And we have this catch-all alias of all. And that's just basically every single country. So if you want the purview of Wordsmith to be every single region that we have data for, you would use all. So with boundaries defined, now we have attributes. And again, these are the types of words that we're generating. You can see a lot of them listed there, and we're not going to go through all of them. The ones I want to call your attention to are the first one underneath the input options, that -A flag. That's going to capture every single attribute listed there. And the other special one is the -B flag just underneath it. This is our miscellaneous/other option. And this can grab text files that you've added yourself or that don't fit one of these already predefined attributes. And we'll go into an example of that. So examples of what it looks like on the command line, if you're grabbing zip codes for California, your input would be USA-CA, and then -Z for your zip codes. For all the roads, cities, and landmarks within England, you have to specify your input as GBR-ENG, and then -R-C-L. If you want to grab all the attributes for Asia, remember Asia is one of those regions that we have already a definition for of all the Asian countries. And then use -A flag for all of the attributes. So it's going to grab every single possible word that it can for Asia. Now, if you're curious what attributes are available for each boundary, we create this thing called child nodes. So you give an input boundary, in this case GBR for Great Britain, you give it the -C flag, and it's going to show you this hierarchy of data. So it starts with Great Britain at the root, and it shows you that you can get cities and counties and landmarks, and then traverse down into Scotland and Wales and England. England is broken out by historic counties, and then in some cases like Sussex, they're broken out into administrative counties. So you can even get as granular as East Sussex or West Sussex for getting cities, counties, and roads. When you call a certain attribute, so if I want to get all the cities for Great Britain, it's going to start at the top and then traverse down to each of its child nodes and then combine all that data together. So we touched on the CIO World Factbook and some of the metadata that we pulled out. This is an example of Japan's. So in that directory, you'll see jpn.yaml. In the middle, you see what that config file format looks like. So we're grabbing the population, we're grabbing the most common languages spoken, we're grabbing the most popular religions, and we can use these for some interesting queries. So we've already talked about the most populous countries query. For religions, or the -G flag, we've used that data from Project Gutenberg where we've parsed out several religious texts, so the King James Version of the Bible, the NIV, the Quran, and some of it in different languages. And now when we look up that country in the YAML file, we can see its markers for which religion, which religion it's part of, and we can pull in the religious text for it. So in the middle there, you see one way of how we're parsing that. We're doing it by kind of Bible book and then chapter and verse. So you see Genesis 1:1 or 1:1 Genesis. I don't know how many of you have done hash cracking in the South, but there's a lot of John 3:16s and Psalm 23s hanging out there. At the bottom, you have another way that we're parsing Bibles, was just grabbing every single word possible from them. On the languages side, with the -V option, we found what the languages were the most frequent across all the countries we had data for, and then we grabbed the 13 most popular ones, starting with English and working our way down. And then we built those dictionaries for English and French and German and so on. So we look up a marker like the US, and we see that it has English and Spanish as its two most popular languages. We'll pull in the Spanish dictionary, we'll pull in the English dictionary. Now with this rewrite of Wordsmith for version 2, we talked about our modular design. And this is kind of what it looks like in action. So let's imagine that you wanted to include words for all the lakes in Minnesota. So you go out, you find a data source, you parse it, and then you create a text file called lakes.txt, and you place it in the appropriate directory. So it's placed there in USAMN. That format should be new line delimited. It should be sorted alphabetically. It just helps with some of the processing. And then you can immediately query that with Wordsmith using that -B option that I mentioned before. This is a data file that doesn't necessarily match one of our predefined options, but we still want an easy way to grab that data. Now the reason that we formatted it like this is because we wanted it really simple for folks to add their own data and also contribute back to the project. All you need really is just a text editor and the ability to go out to GitHub and upload a file, and you can submit pull requests to us. And that way we can share data with everyone else. So we've got our boundaries, got our attributes. Now we want to start tweaking the output. By default, Wordsmith is going to print all the words to console. If you want to, instead of writing them out to a file, just use -O. If you want to quiet the output, so you're not logging up your console there, you can use -Q. The middle section there is for placing some restrictions around the words that you're generating, or if you want to do some like word mangling. So you can set a minimum length, you can set a maximum length for your words. You can use -D for Windows default complexity. So if you only generate words, because you know you're cracking hashes, where the password policy was the Windows default of 8-character minimum and then 3 out of 4 cases of upper, lower, numeric, and special, that option will filter out any words that don't meet that standard. -J for lowercase, in case you want to port it into like a hash cracking tool. The next 3 options, you can strip out spaces, you can strip out special characters, you can split on spaces. If you want to do all those things 3 things at once, just use the mangle option -M. It's very basic word mangling. Then the bottom section there is for prepending and appending certain words. So like zip codes or area codes, or your own custom word list. So example of tweaking the output, let's say you're generating roads for DC. So use USA-DC as your input, -R for your attribute. And one of the words that pops out is Pennsylvania Ave with a space and a period at the end. If you drop a -M at the end of it and start mangling that word, you see that we can remove the special characters or split on spaces or remove spaces entirely. You've turned one word into 7. So it's just some basic word mangling. If you want to specify a minimum character length, you do that with -A, so -K. So we're only going to keep words that are 8 characters minimum. That -D will do the Windows default complexity. So now we're only passing words that are going to meet the 8-character minimum with 3 out of 4 cases. If you want to write all of these words out to a file, the syntax looks like that. So in this example, instead of just doing roads, we're doing -A for every attribute of DC. We're doing -Q to quiet the output and -O to write it out to a file. And this is kind of what the output looks like, where it will enumerate through every single attribute of your boundaries, show you how many words it generated. Then at the very end, it'll do this big sort and unique and write all those words to a file. So for DC, this generates a little over 1.2 million words. I don't know if you guys saw this article about a year ago in Ars Technica. It was about an alleged drug dealer who got rich from selling illegal drugs on Silk Road. And his machine was eventually confiscated, and they found his PGP key and they tried to crack it. And what they found was his password was that dictionary word followed by 209, which happened to be the zip code or the area code of where he lived in California. And Sanj and I saw that and we were like, this is too good. We have to include that functionality in Wordsmith, because this article came out right when we released Wordsmith last year. So you can use those options you see on the side to append or prepend zip codes, or to even splice in your own word list. So an example of how you might use that, if you have this file years.txt that has 17, 2017, 17 and 2017 bang, and then you go to Wordsmith and generate some words. So here we're generating words for DC. We're grabbing all the colleges with -F. We're mangling the output with -M, and then we're going to append all of the years to it. So you have Gallaudet, and then you see all of our custom words appended to it. So Gallaudet 2017 or 2017 bang. Or at Georgetown, it's going to pull out the mascot for it. It's got the Hoyas, and Hoyas 2017 bang. You're generating words that look like they might actually fit a password for someone who lives in the area. Names, like we touched on before, from the Social Security Administration. We're doing a couple things with them. One, you can just grab them as normal attributes. So if you want to grab all the first names for a particular area, you can do that, or all the last names. Or if you want to grab all names, you can do that. We're also using this for username generation. This is the only the only files that we keep that aren't already sorted. These are arranged from most popular names down to least popular. So when we get over to username generation, and we saw this as a new avenue, because our focus of Wordsmith initially was generating words for password cracking or password spraying attacks. Now we've got this idea that we can generate usernames that are particular to a certain area. So the format of that would be kind of some examples you see at the top: first initial, last name, last name, down to first name dot last name. There's some options at the bottom. If you want to truncate usernames, or if you want to control how many usernames you're setting, you can use those options. So to give you an example, if you're generating first names and last names for the US, you see James Smith, James Johnson, James Williams, and so on. At the bottom, it's first name dot last name, same output with the dot in there. If you see, it's grabbing the most common first names and then matching those up against the most common last names. That's how it's going about the generation process. Let's say that maybe you're going up against a mainframe that likes to only use 8-character usernames. You can use this -- truncate option, specify a number, and it will truncate all your usernames at a certain character length. If you want to adjust how many words you're generating, by default, our sane default was 100, so it's going to grab the 100 most common first names, the 100 most common last names, and match them together. And that gives you 10,000 usernames that's generating. If you want more, you can specify this name depth option, and it's going to use the 250 most popular first names and 250 most popular last names. Or if you go up to 1,000, it's going to end up generating 1,000,000 different usernames for you. And with that, I'll pass it back to Sans for the demo.
Yeah, thanks, Tom. So last year we did a live demo, and it went pretty well, I think. But this year we elected to go with a pre-recorded demo. I guess just for the context, but what we're going to be doing is we're going to be generating a word list for the country of Ireland. I was recently in Ireland doing a pen test there, and I extracted the ntds.dit and dumped the NTLM hashes for a particular Irish client. Now, we're going to be using this Irish word list to crack these Irish hashes, and just looking at some of the cool passwords and interesting passwords that we recovered that are geolocation-based. Let's get out of this. You guys ever heard of ASCII-NEMA or ASCII-NEMA before? Anyone? A couple people? One or two? Cool. So whenever I'm on a pen test, if I'm recording my console output, before I was using script, and it's great, and it just kind of records anything you put into console and out of console into log files if you want to preserve evidence or kind of track what you're doing. But I found that escaping like control characters can be a bit of a pain. So ASCII-NEMA just creates these really nice JSON blob files which you can pull back into and just kind of like copy and paste text out of really nicely. So, that aside, essentially what I'm doing here is I'm creating a Irish word list using the 3-letter ISO country code. Almost immediately I put the quiet flag in there because I don't want to see a verbose output of all these input options out to screen. But when I'm creating a word list, I'm typically including all of the options, and I might toss in some mangling in there as well. So, can we see that on screen okay? Just going to fast forward a little bit here. But yeah, so that's a generation of the Irish word list. So you're seeing the CIA demographic data, you're seeing the OpenStreetMap data come out, and some of the Wikipedia data as well. Religions, probably Catholicism, maybe Catholic as well, and languages is probably going to include the English dictionary, and I think there's an Irish/Gaelic dictionary as well. But yeah, roughly 12 seconds to generate an 800K word list. Quickly touching on roads. Initially, as I was looking at roads as a data set, I was thinking more about, I thought that a lot of the data in there would be basically numeric street values, right? But what I came to realize was there are so many roads, even in the United States, that kind of have the name of influential people, or, for example, Martin Luther King Boulevards, right? Or New York avenues, or those data sets kind of transfer across the world. So you'll have a nice set of names in there as well, which might be part of people's passwords. But yeah, so we've created this word list, and I'm going to start cracking some hashes here using hashcat. So I'm just removing the hashcat pot file. Shouldn't really do this because it's got a nice little mapping of every single crack you've ever done. But for the demonstration purposes of this video, these are real NTLM hashes extracted from an Irish client. So we're using the attack mode of 1000 NTLM and then straight up brute force. Using the dead hob0 or dead hobo rule set. So I'm not sure if you guys are familiar with that, but Tom and I have had great success with it. It's about 50,000 different rules, and these rules will add different mangling options as well as append certain things or prepend certain things and do title casing, camel casing, character substitution, so 4s become ats and A's become ats and that sort of thing. But what you're doing is you're taking that 800,000 word list that you've created and basically performing that 50,000 character or word substitution and operation on every single one of those words. So now you're expanding your list from 800,000 to 800,000 times 50. Yeah, so kind of looking at this hashcat output here, there were 533 unique hashes, but there could have been maybe 600, but it distills it down to unique because some of the passwords might be reused for certain service accounts or common domain user accounts, whatever that may be. And of those 533, within a minute and 20 seconds, we cracked 101 of those, which is a pretty decent recovery rate of 20% for a geolocation generated word list. This is just on my MacBook Pro, so they're not going to have the fastest GPU cracking speeds here, as opposed to like a cracking array of some sort. But yeah, I guess looking at some of these passwords, some of the more interesting ones are kind of on the right-hand side, but you'll get the common sort of city names. You'll also get, having recently been there, you'll also get some things like landmark names. So Temple Rowan's a landmark there in Tipperary and Portishead. Interestingly, you'll also get some really cool last names like Wolseley and Donegal and Ferriers. This last one is an actual real address as well. So 5 Road the Abbey. There's a business that's located there, and that's kind of just what the address is. Now, so you're not always going to be on site and extracting hashes for just one particular geo set or sort of organization which is based in one country, right? The more common approach is you're going to have multinational organizations which span across different countries, have satellite offices everywhere, and even headquarters in different countries too. So this next statistic is for a multinational organization which I recently obtained the hashes for that has offices in the USA, Australia, and Canada. And as you can see in the Wordsmith command there, I'm using the -J flag, and that's just reducing all of the, that's just taking all the words in the Wordsmith generated word list and making them lowercase, because I'm going to be applying more sophisticated cracking rules to those later in terms of dead hobo. So yeah, top 10K, it's just the top 10K passwords. It's going to grab you about 256 passwords in 4 seconds in conjunction with those dead hobo rules. Rockyou, which is a really common word list, grabs another 476. And then our Geo word list for Australia, Canada, and the US is about 7.3 million words. It takes about 13 minutes to run, and will grab you another 241. So looking at some of those passwords as well, Australia's got a really high character length password for Queenslander, which is just someone who lives in the province of Queensland. You've also got a couple different cities and towns there. But yeah, kind of all sort of geo-based data. Canada, nothing too interesting there, just the country name and a popular city in Canada. Matthew 2222 is probably a reference to a book and a verse and a chapter of one of the Bibles. And then the USA, you've got common tourist destinations, some sport teams, and then transportation lines and political Canada news as well. Okay.
So Sanj and I spent kind of a monumental amount of effort trying to create these parsers for all these different repos. Sometimes we're going out to the internet and scraping websites. Sometimes we are pulling down files locally and parsing them in various different formats. So we wanted to preserve that. So we created this other GitHub repo at wordsmith_parsers. You guys can go in and see all the random assortment of Bash and Ruby and Python scripts. It's also an opportunity for you to contribute back. So if you submitted some data and you write some parsers to get that data, feel free to send us a pull request. Future work and where we see Wordsmith going from here. Data is always going to be something at the forefront and always will be with this project. So we'll probably dive deeper into things like OpenStreetMap. There's a lot of other interesting attributes you could pull out of there. Things like cafes and airports and bodies of water, just interesting proper nouns specific to that particular boundary. Popular song lyrics. So this was a recommendation from Patrick Fussell sitting right over there. What if you took the Billboard Top 100 for a given country at a certain time, found all those songs, and then parsed out all the lyrics from those songs? You can break it up by phrases or verses. You can ingest those into Wordlist. But if you got ideas, we'd love to hear them. Send us a pull request on GitHub, submit a new issue, reach out to us on Twitter. We'd love to chat with you, especially if you have skills, like GIS skills. Sanj and I, this is kind of a fun project as a hobby on the side. we don't have that GIS background or experience. If you do, I think we get a lot of value out of you. So feel free to reach out. Multiple language speakers sometimes are reaching out to these really strange foreign language websites trying to find data sources. And Google Chrome Translate can only take you so far sometimes. So if you got those skills, that'd be great. Or if you just like hunting, in the deepest, darkest parts of the internet and scraping data from it, that would be very helpful. In terms of design, where we're seeing version 3 of Wordsmith going, my kind of pipe dream is changing how you can specify your inputs. So instead of just doing at a country level or a state level or a county level, whatever it is, what if you put in like an address? What if you put in a pair of geo coordinates and then say, give me all the words within a 50-mile radius of this? That's what we'd like to go for version 3. So with that, I'd like to say thank you, and I think we have some time for questions. Yes?
Have you looked into using demographics in addition to location-based wordlist generation?
Have we looked into using demographics along, so what kind of demographics in particular?
Age ranges.
Sure.
Yeah.
Yeah, that's a really good point.
Me too.
Yeah, no, we haven't. That's a really good point, though. I guess that would be, for very specific targeted attacks, maybe for a small set of users or one particular user, right? No, that's a great point that we didn't consider or haven't done, but we'd love to talk about it as well. Any other questions? Hey, yeah.
Character sets, I'm guessing just UTF-8 for everything.
Yeah, UTF-8's the way to go. What's that?
I was like English line-based character sets on the screen, but it works with like.
Yeah, with some of the language files that we're using, we've got anglicized versions of those. So the UTF-8 helps there, and then particularly with the Russian character set, some characters had to be stripped, but they can be converted to be read in properly as well. So, yeah, that's a really good question. Anyone else? Cool. Well, we'll be around and we'll be attending other talks, and it was great having you all guys, or having all you guys here, and thanks so much. And hope you have an excellent con.